So we have question number 56, which says that consider the following statements and identify the correct statements with respect to molecular orbital theory. So the first statement says that constructive interference of wave functions lead to formation of bonding molecular orbitals. So whenever two atomic orbitals combine, so two molecular orbitals are formed. One is bonding molecular orbital and another is anti-bonding molecular orbital. So the bonding molecular orbital is basically the addition overlap. And which is also known as the constructive interference of two atomic orbitals or wave functions. And anti-bonding molecular orbital is formed by the subtractive overlap, or we can say the destructive interference of the wave functions. So the first statement is absolutely correct statement. Now we have the second statement, which says that the sigma and pi bonding molecular orbital don't contain nodal planes. So this is absolutely incorrect statement, because if I draw the pi molecular orbital, which is forming by the lateral overlap of two p orbitals, so we have here, this is px and this is px. So when these orbitals combine to form the pi bonding molecular orbital, so we can have the scenario like this. So this is plus and this is minus, and this is the nodal plane. So the nodal plane also exists in the pi bonding molecular orbital. So this statement is absolutely incorrect. Now we have third statement, which says that the mixing of s and p orbitals can change the energy order of sigma and pi bonding molecular orbitals. So this is known as the sp mixing, and whenever the sp mixing takes place, it changes the energy of the sigma and the pi bonding molecular orbitals and reverses the order. So this is the absolutely correct statement. So we have the correct statement, that is first and 3. So option number 4 is the correct answer. So moving on to the next one, students, we have question number 57, which says that the type of bonds present in CuSO4.5H2OR. So first of all, draw the structure of this compound. In this structure, four water molecules are coordinated to copper 2+ ion. So this is the coordinate bond. And now we have the fifth water molecule, which is involved in the hydrogen bonding with the water molecule and with the sulfate ion as well. So this is the sulfate ion. So here you can see that we have coordinate bonds, we have covalent bond, we have hydrogen bond, and we have electrovalent bond. So all the four bonds are present. So option number 3 is the correct answer. So moving on to the next one, students, we have question number 58, which says that which of the following pair of species have same molecular shape and hybridization of the central atom. So in the first option we have SO2 and we have CO2. So if you draw the structure of SO2, we have two bond pairs and plus one lone pair. So the hybridization is sp2 and the shape we have, that is bent. So now if you draw the structure for CO2, In CO2 you have 2 bond pairs plus 0 lone pair. So the hybridization is sp and shape is linear. So this option is incorrect. And in the second option we have SF4 and CCl4. So in SF4 we have 4 bond pairs plus 1 lone pair. So hybridization कितनी हो जाएगी? sp3d and the shape is seesaw. And now draw the structure for CCl4. So in CCl4 you have 4 bond pairs plus 0 lone pair. So hybridization हो जाएगी sp3 and the shape will be tetrahedral. So यहाँ पे दोनों molecules की shape भी different है, hybridization भी different है. So this option is also incorrect. Now we have the third option XiF2 and I3 negative. So in XiF2 we have 2 bond pairs and 3 lone pairs. So hybridization हो जाएगी sp3d. So the shape will be linear. And now we have I3 negative. In I3 negative the bond pairs are 2 and the lone pairs are 3. So here also 2 bond pairs plus 3 lone pair. So hybridization हो जाएगी sp3d and the shape will be linear. So in this option both the molecules have same hybridization of the central atom as well as the same shape. So this option is the correct option. Now see the fourth option as well. In the fourth option we have water molecule and the ammonia. So in water molecule we have 2 bond pairs and 2 lone pair. So hybridization will be sp3 and the shape will be bent. Now if I talk about NH3, in NH3 also we have 3 bond pairs plus 1 lone pair. So hybridization will be same, that is sp3, but here the shape will be trigonal pyramidal. So this option is also incorrect option. So the only correct option that we have find out, that is option number 3. So moving on to the next one, we have question number 59, which says that the HNH bond angle in NH3, NH4 plus and NH2 minus are in the order of. So first of all draw the structure of these 3 species. So in the first one we have NH3 molecule. So अगर हम NH3 molecule को देखें, so in NH3 we have 3 bond pairs and plus 1 lone pair. So the hybridization is sp3. So now draw the structure for NH4 plus. In NH4 plus we have 4 bond pairs and 0 lone pair. So hybridization to sp3 है, but shape is different now. Here the shape is tetrahedral and in ammonia the shape was trigonal pyramidal. And now you have NH2 negative. In NH2 negative you have 2 bond pairs plus 2 lone pair. So here the hybridization remains same, that is sp3, but the shape is different now, that is bend shape. ठीक है, अब हमें यहाँ पे क्या फाइंड आउट करना है? दी HNH बॉन्ड एंगल, दैट इज दिस बॉन्ड एंगल. सो हम यहाँ पे देखते हैं कि जितने ज्यादा लोन पेयर प्रेजेंट होंगे उतना ज्यादा क्या होगा? लोन पेयर और बॉन्ड पेयर में रिपल्शन होगा, और जितना ज्यादा रिपल्शन होगा द बॉन्ड एंगल विल बी लेस. सो सबसे ज्यादा लोन पेयर किस में प्रेजेंट है? NH2 नेगेटिव में. सो द बॉन्ड एंगल विल बी वेरी लेस. एंड इन द केस फॉर NH4 plus, no lone pair is present, so the bond angle will be highest in case of NH4 plus. So the highest bond angle will be of NH4 plus, followed by NH3, as there is only one lone pair, and the least will be for NH2 negative as it has 2 lone pairs, so there will be more repulsion. So the correct order will be option number 2. So moving on to the next one now, we have question number 60. So which says that the correct order of polarizing power is. So polarizing power depends upon charge and radius of the ion. So polarizing power is directly proportional to charge on the ion and inversely proportional to the size. So जितना ज्यादा चार्ज होगा उतनी ज्यादा क्या होगी? पोलराइजिंग पावर. एंड जितना कम साइज होगा आयन का उतनी ज्यादा क्या होगी? पोलराइजिंग पावर. सो वी हैव बेरिलियम 2+, we have magnesium 2+, we have calcium 2+, and we have K+. So you can see here the highest charge and the smaller size is of beryllium 2+. So it will be having highest polarizing power, followed by magnesium 2+, followed by calcium 2+, and followed by potassium plus, as the potassium plus has the largest size and the small charge. So the correct order will be option number 4th. So moving on to the next one now.